Hello, so today we are now going to give an example and when can we say that a function is differentiable or not differentiable. But before we move on to that example, let us discuss first important remarks in relation to differentiability. First, let us recall that differentiation is the process of computing the derivative, and at the same time it is the operation of deriving a function f prime, where f prime here is actually the notation for derivative from the function f. Okay, the number 2, if a function has a derivative at x is equal to a, the function is said to be differentiable at x is equal to a. Meaning to say, if the derivative of the given function exists at x is equal to a, then we can say that that function is differentiable at that value, x is equal to a. Number 3, another important remark, if a function is differentiable at every number in its domain, then it is called a differentiable function. Okay? Last important remark to remember is differentiability implies continuity. Okay? We already discussed about continuity in the previous video. Okay, we are now ready to give an example on determining whether the function is differentiable or not differentiable. Okay, so for example, let g of x, okay, is equal to the square root of x. Now the problem is g of x differentiable at x is equal to 0. Okay, that's the problem. Let g of x is equal to square root of x. Then is g of x differentiable at x is equal to 0? Then if that is so, justify your answer. Justify your answer. Okay. Then determine all the points, okay? All the points or domain where f is differentiable. Okay, again, let us read the problem. Let g of x is equal to the square root of x. Now, is g of x differentiable at x is equal to 0? Justify your answer. Determine all the points or domain where f is differentiable. Okay. Now, in the previous topic, so far we discussed the formula for finding the derivative that is using its definition. So in solving this problem, let us first discuss and use the formula for finding the derivative, because if we go back to the important remark, we can say that a function is differentiable if what? If the derivative exists at x is equal to a. So in this case, what is our a? At x is equal to 0. So a is equal to 0 in this case. Okay? So let us first solve the derivative. Solution. Okay? What is g prime? G prime of x, recall, is given by the limit of g of x plus h minus g of x over h as h approaches 0. Okay, that's the formula for finding the derivative using its definition. Using the formula, what is g of x plus h? So take note that g of x is square root of x, right? So since g of x plus h, all we have to do is just to add h to the variable x. So this becomes limit of square root of x plus h What is g of x? The g of x is square root of x over h as h approaches 0. Okay, now to get the limit of this expression, we need to multiply this whole expression by what? By the conjugate of the numerator, that is equal to 1. So we need to multiply, if this is minus, we need to multiply square root of x plus h plus square root of x over square root of x plus h plus square root of x. So this is how we simplify this expression, that is by multiplying by the conjugate of the numerator, which is equal to 1. So if we're going to take note of this expression is the same as this expression, so this is equal to 1. Okay, so simplifying that equation, so take note, this is equal to the limit square root of x plus h times square root of x plus h. This is x plus h minus square root of x times square root of x. Okay, square root of x times square root of x is x only, over h times square root of x plus h plus square root of x, okay, as h approaches 0. Right? Now, we can simplify square root of x plus h minus x. So this will be cancelled. So we have limit of h over h times square root of x plus h plus square root of x, right? And we have common factor here, h and h. So this is 1 as h approaches 0. So this becomes a limit of 1 over square root of x plus h plus square root of x as h approaches 0. Again, this is rational expression. The limit of the constant is 1 over the limit of this expression as h approaches 0. So this will be 0. So we have square root of x plus square root of x, right? Which is equal to 1 over 2 square root of x. So in other words, our g prime of x is equal to the 1 over 2 square root of x. That's our derivative. Okay? So, question. Let's go back to the question. Is g of x differentiable at x is equal to 0? To answer that one, we need to identify or determine whether the derivative exists at x is equal to 0. Now take note, at x is equal to 0, g prime of 0 becomes what? 1 over 2 square root of 0. This is undefined. Undefined, right? Because we have a numerator 1 over the denominator 0, because square root of 0 is 0 times 2 is 0. So we have 1 over 0. So this is undefined. Undefined meaning the derivative, therefore, g prime of x does not exist. What does it mean? The derivative does not exist, hence g of x is not differentiable at what value? At x is equal to 0. Okay? So it's not differentiable. This is g. So g of x is not differentiable at x is equal to 0. Now, we have answered the first question. The second one is determine. Okay, determine all the points or domain where f is differentiable. Okay, so what are the points that make the function differentiable? So we have to determine the domain of g prime. So what's the domain? Okay, take note that g prime of x is equal to 1 over 2 square root of x. Now, what's the domain? So, what's the domain of this? Or when is g prime become what? Or when does g prime exist? At what point or points? So this is defined, take note, this is defined if x is in R, okay, such that x is greater than 0, right? So this is now the domain. This is defined if the values of x taken from the set of real numbers is greater than 0. So what's the domain again? This is x in R, which is the values of x taken from the set of real numbers such that x greater than 0. This is set builder notation, which is equal to 0 to positive infinity using the interval notation. So we were able to answer the problem. That is, first, we were able to determine that g of x is not differentiable at x is equal to 0. And the second one is we were also able to determine that the domain where f is differentiable is 0 to positive infinity. So hope you like this video. Thank you so much and God bless.